Hey, this is Andrew Brown, your favorite cloud instructor.
Hey, it's Ashish Rajani, your favorite cloud security instructor. Today, I'm here to talk about GitHub Advanced Security Certification, or as called GHAS with love.
And the way we're going to get certified is, as always, we're going to do our hands-on labs in our own accounts, the lecture content, and going through a practice exam. And as always, we provide you a free practice exam. I want to remind you, if you like cloud certifications and this expansion into security certifications with our friend Ashish, the best way to do that is to purchase the optional additional study materials on the Exam Pro platform. But let Ashish tell you a little bit about himself.
For those of you who probably have not heard of me before, I am the host of a popular podcast called Cloud Security Podcast. I've been in the cybersecurity industry for over 14 years, teaching cloud and cloud security to a lot of people as well through SANS. In fact, I was part of Andrew's free code camp that we did a few months ago for AWS. So I look forward to having all of you enjoy the certification course that we have created here for you guys. Let's get into the course.
All right. See you soon. Ciao.
Ciao. What is GitHub Foundations? GitHub Foundation is the entry-level GitHub certification that teaches you GitHub version control basics. How do you develop programs? How do you manage projects that are running in GitHub? There's a lot more that's involved in this. The unofficial course code for this is GHF. But one thing to note over here is that GitHub is still the leading version control service in the world. And GitHub is still the most common way most developers showcase their code either to their employers or companies using it for storing their own private code as well. So from that perspective, understanding GitHub and GitHub related products are quite crucial for most developers out there. Who is the certification for? Consider this. GitHub Foundation is important for people who are either new to cloud programming. You may not even be a developer in a tech role, but want to develop the skills for a developer, and you want to showcase that portfolio to a potential future employer, or you just want to learn version control fundamentals. All these reasons could be substantial enough for a lot of people based on where you are in your journey on learning and understanding GitHub. And it would test your skills for how much you understand Git by itself. And Git has its own, knowledge curve that you need to understand before you jump onto GitHub. So in case you're thinking of going for GitHub Foundation, I would definitely encourage you to learn Git first and then come for the GitHub certification. Talking about GitHub certification roadmap, it is advisable that you probably start with GitHub Foundation, which is considered level 100, especially if you've never done much work in GitHub yourselves. You're probably having an understanding of Git and GitHub would be very valuable and probably worthwhile spending some time on GitHub Foundation passing that exam. Followed by either you can choose the GitHub Advanced Security, which is great for cloud security engineers who probably look at programming and are also looking at automating a lot of the cloud security features that they may be working on, whether it's building infrastructure as code or whether it is using Terraform or other languages in CloudFormation. I can keep going on. Or you can just choose the path of being a better developer by understanding GitHub Actions. Now, having an understanding of GitHub Actions is good both from a security and from a development perspective. As you get better at this, from a security perspective, the next evolution would be to become an enterprise engineer. Now, it's worthwhile calling out GitHub does not validate programming, technical diagramming, code management, and a lot of other skills are required for the role of a developer or even a cloud security engineer in any organization. However, this at least is a way for you to showcase to your future employer or your current employer that you understand some features and essential things that you might need to work on a day-to-day basis in GitHub. How long it would take you to study? Depending on where you are with your level of understanding of GitHub already, you could be looking at anywhere, if you are starting today and have never done GitHub or written any kind of line of code, you're probably looking at 20 hours plus of work. However, if you're an experienced person who's looking to do GitHub Advanced Security, you have enough years of experience in GitHub itself, you probably already have some technical knowledge in GitHub and Git and have a strong background in technology. And doesn't have to be all kinds of technology, at least one or two, which is just good enough for you to be decent at understanding the flow of how languages are stored in version control, how you can manage them, a lot more of those basics as well. In that case, you probably only need 4 hours, but on average, you're probably looking at 14 hours of average study time with 50% lecture and lab and 50% practice exams. I would definitely recommend you to study 1 to 2 hours a day for a 14-day. What does it take to pass the exam? Exam Pro and myself are huge believers of video lectures, hands-on labs that are related to an actual project. And doing some online practice exams are definitely, if you can find a paid one, definitely great. There are some free ones as well on Exam Pro if you wanted to check that out. But doing those three, just watching lectures, one video from an experienced trainer, having hands-on labs that you can follow along on your own GitHub account, and having a way for you to practice online tests that are available from other organizers or even free and paid ones as well, definitely would be a great way to make sure you definitely pass the exam. Now, from a content perspective, there are 7 domains that have been shared by GitHub. The domain 1 will describe GHS or GitHub Advanced Security Features and Functionality. Domain 2, 10% for configure and use secret scanning. Domain 3, 15% for configure and use dependency management. Domain 4 for 15% configure and use code scanning. Domain 5 for use code scanning with CodeQL. And domain 6, 20% describe GitHub Advanced Security Best Practices. And domain 7, 10% for configure GitHub Advanced Security Tools in GitHub Enterprise. Now, how would you even take the exam? You can give the exam in person or online at your own convenience from your home. You would be using the provider PSI Online, or they have a network of test centers as well. You could find the closest one that is in the city that you're in using the Google search to find out the closest center you have for PSI next to you. Now, it's worthwhile calling out, online version would have a proctor or someone who's basically supervising and looking at what you're doing while you're giving the online exam. So that's something that you should be wary of. In a test center, there are already people monitoring you. So I guess it depends on what you're more comfortable with, doing it online or doing it in person. Now, it's worthwhile calling out, GitHub does not provide a passing score, but having a scoring of 75% correct answers would ensure that you pass the certification. As I said, there is no passing score, but at least aiming for that 75% correct answer would ensure that you pass the certification. There are 75 questions in the exam, 60 scored and 50 unscored. Now, unscored are the tricky ones where they don't really mark you on them, but they're definitely there and you would not know which ones are those. So you can technically afford to have 15 scored questions wrong. There is no penalty for wrong answers, so you might as well give answers to all the multiple choice and multiple answers that are available. 15 questions of the exams are unscored, so they would not count towards your final score. Unscored just means that they would not be used to mark you, but they would be used for introducing any new questions in the future. This also helps in determining if the exam is too easy and the passing score or the question difficulty needs to be increased. And also to discover users who are attempting to cheat the exam or just steal dumb questions. Hopefully you're not one of them and you're just basically following what we teach you, which is video tutorials, hands-on labs that you follow along, and finally just some practice online labs or practice exams that you're following along. And one final point, if you encounter a question that you've never studied for, keep your cool and remember there would be unscored questions as well. Now, the total duration is 2 hours and 1.6 minutes per question is the time you have. I would say exam time by itself is 120 minutes. The seating time is 150 because you have to account for the fact that when you start, if it's an online exam or if you're going to in person, you would have that 10-15 minutes of showing your ID, verifying. If you're doing the online exam, they would look at the webcam that you have given them and also consider the fact, are there any items on your desk? They would make you clear it. So 15-20 minutes, that would be probably in the beginning, maybe 20 minutes, and then towards the tail end as well, where you might be asked to submit a feedback. Assuming you have done Git Foundation and you've gone through some of the other lectures we have on Git Foundation, having a basic understanding of Git, I'll just do a quick refresher for everyone to be on the same page, in case the last time you went through this was some time ago. Git is a distributed version control system, or DVCS, which is created by Linus Torvald. Hopefully I did not mispronounce the name, but Linus was the creator of Linux kernel. So potentially it's Linus, but I don't want to call it, I feel it's Linus, so apologies if I got that name wrong. Now, Git is how you interact with the version control system. Each change on your code, which can be committed by a command called git commit, and can be tracked before for how it was before the change, how it is after the change, and what is the change being made. Now, GitHub is a version control service. I would even say it's like a SaaS service, which allows you to access Git-based version control system from anywhere on the internet. It is a hosting managed remote Git repository to, I guess, people like the technical term, but they have expanded to other offerings as well. Like, for example, now you can also have project management tools, pull requests, code reviews. GitHub has even got GitHub pages and wikis. GitHub Action is something that you would hear about in other certifications, but also as someone who's working in cybersecurity, you would also hear about GitHub Actions as a way to automate a lot of the code and being able to trigger security tooling when a certain action happens. GitHub Pilot is also catching a lot of traction, which is the AI-based product that has been launched by GitHub. GitHub code spaces, marketplace, there's a lot more that's being added on. And worthwhile knowing that you don't need to know all of these for the exam, but this is just a quick refresher on what GitHub is. And fun fact, GitHub was originally written using Ruby on Rails. Common Git terms for those who don't remember at the moment: repository, commit, tree. I would probably say the most common one that you would use quite often, even if you start from the top, which is repository, which represents a logical container holding the code base. So a lot of people talk about, hey, this is my link to my repository, very common word. Commit is a change of the data that you do to your local repository that you commit onto the branch that is local on your laptop. Now, you would use something like a branch to create a new branch, depending on the practice you have in your organization. Now, remote would be if you are hosting a project, a version of your project somewhere, but you want to exchange commit, you would be a remote. Cloning or clone is basically, a friend of yours or someone you know on the internet has created an amazing repository that you want to work with. You can use clone to clone that repository and make it better, or just start using it yourself as well. Also, make sure when you're using a repository that you're cloning, make sure you have at least have a look at the license that they have, Apache license or MIT license. These are important for enterprise that are using it, because not all repositories on GitHub are free to use. They do have license requirements that you should look at, especially the README file. Now, we spoke about repository, commit, branch, clone. Checkout is to switch between different branches in your local repository. And probably the next two important ones are pull and push. Now, the pull example is that I have been working on a local repository for some time, and now I have finally may realize that, oh my god, people have been still pushing changes onto the main repository. So now I am running a few commits behind the main branch, and that's how you can pull some of the changes from your remote repository, which may be at github.com, and merge that into your branch, so your branch has the latest information on all the code changes that happen. Now, once you have done that, you may want to push that change, the keyword being push. You may want to push that change to the local from the local repository to your remote repository on github.com. The same goes for fetch. You can download data from a remote repo without integrating it into your work. Reset undoes any local changes with options to unstage or revert commit. Basically, you might make some changes, but you're not like, oh, I don't really think I wanted to make those. You can just use the reset button to undo all those changes. Now, this is going to unstage any commits you would have made locally that you have not pushed to the remote repository. So worthwhile knowing, the changes should still be on your local repository. If they have been pushed onto the remote repository, then the reset is not really going to change anything on the remote repository itself. Merge can combine commit histories into one. Staging files prepares and organizes changes for a commit. Now, commit saves your changes as a snapshot in the local repository, and adds changes to the staging area of the next commit. Now, we have explained what a repository is. A GitHub repo is your GitHub repo when you push upstream to GitHub. GitHub allows you to access and manage your Git repo with several functionality. You could use GitHub installed locally on your laptop to view different branches. If you have cloned a repository, you can view different branches. You can look at the tags that are being used, commit history, and a lot of related information around releases, code bases, but you can also perform actions. Like, for example, you can put yourself on the watch list. You can start watching the repository for any changes. You can even fork from it, where you can create a separate branch or a separate, I'll probably say a separate version or a separate version of the project and make it your own. Or you can clone that to download that locally. A Git commit represents the incremental changes to a code base represented with a Git tree graph at a specific time. The simplest example for this is that you have made some changes after you have cloned a repository from github.com or another source, and that you made into a repository, and you're ready to commit that into a branch, potentially the main branch of the GitHub you're working with. Then you can use Git commit to commit the changes onto GitHub. Now, each commit does have a SHA hash that acts as an ID, and it can have actions like addition, modification, deletion, and it contains pieces of information for the changes, but it may not contain the whole file. A Git branch is a divergence of the state of repo. It's almost like you want to keep the original code base intact, but you would want to start making some changes that you can bring back onto the main code base. In this case, the example we have provided is a feature branch 1 and feature branch 2, a production branch, a main branch. Now, going by feature branch and main branch is the active code that is something that everyone is happy with. It is stable, and that is then pushed on to production, which is the production branch. Now, you may choose that you want to add a new feature to the application you're working in. You may create a separate branch for it. You would make all your changes, you would commit your changes, you can test your changes, and when you're happy that you've just have succeeded, you would come back to the merge over here. And so you'll go from the feature branch and merge it onto the main branch, and once things are good and tested on the main branch, they can be pushed onto production. That would be an example of a workflow, which is also similar to something called a GitHub flow as well, that you would get to know. Now, Git remote has a concept called upstream and downstream. Upstream would mean that you're sending it from your local repository or your local developer environment onto upstream to where the changes are being pushed to. Now, in this case, it could be the remote github.com. And when you do a pull from a remote GitHub repository, then you're doing a downstream change. Basically, a repository that pulls or clones from another repository. That is called upstream or downstream. What is GitHub Advanced Security? GHAS. GHAS or GitHub Advanced Security refers to the understanding on how to use security features of GitHub to secure your code from security vulnerabilities. Now, if you are already on GitHub, you could probably just go to a repository of your choice. I've just gone to www.cloudsecuritybootcamp.com, which is a website that we run for Cloud Security Bootcamp. You can go to the security tab and you can already see services that you have turned on and are available for you based on whether you have a private or a public repo. Dependabot, code scanning, and secret scanning. It is important to know there are more features as well for a GitHub security, but these are based on the paid plan. For example, from a free and team tier, code scanning, secret scanning, and reviewing or dependency is available for all in public repos. However, no security overview or repo rules are available for free teams. If you were enterprise, however, you would get everything for all public and basically, if you're an enterprise, however, you would get code scanning, secret scanning, review dependency with advanced security, and would also include security overview and repo rules. when it comes to Dependabot alerts and security updates and version updates, that is equal for everyone, for teams and free tier as well as enterprise tier. For a free tier, you would required reviews can be made, required status checks can be done with public repos. In Teams plan as well as Enterprise plan, you can require review and require status checks, but you can do that for all types of repos, both public and private. GitHub Security Advisory is only available for public repos if you are on a free or team plan. It is available, like GitHub Security Advisory will be available in Enterprise Cloud because Enterprise is usually expensive. Now, you do have the capability to do role-based access control, require MFA, audit logging. However, there is no audit log API or GitHub Connect or SAMLs, SSOs, or even an IP allow list if you're on a free or team plan. However, if you're on an enterprise plan, you would get audit log API, GitHub Connect SAML, single sign-on LDAP, and you would also get an IP allow list with your enterprise cloud as well. GHAS or GitHub Advanced Security. Before you dive into this, you probably want to understand, why is GitHub security feature important? Now, as a developer or as someone who writes, shares, and perhaps even develops code, you would want to be proud of the quality of the code you create. Now, usually the quality of the code is deteriorated either by not using the right kind of syntax or creating code that is unsafe, which contains a lot of security vulnerabilities that can potentially harm the production environment that your organization is working on. Now, GitHub Advanced Security, GHAS, is integrated within GitHub and can allow you to check for secrets that are stored in your code. It can allow you to look at vulnerabilities that are probably coming from an open source library that may be used by either a package or a set of libraries in your code. It could also detect vulnerabilities that just could be in the logic of the code or the way the program has been written. Other things to note that are available from GitHub Advanced Security, which are in addition to looking at just how safe the quality of the code is, would be Security Overview, GitHub Account Repository Rules Management, Audit Logs, GitHub Security Advisory, and GitHub Repository Policies. These are security features you can enable around the use of repository and how GitHub is used in your entire organization, which is quite crucial to manage access to sensitive areas of GitHub for developers. Like, for example, you don't want someone or anyone in the organization to be able to simply go and delete production repositories, which is a big no-no. So managing the repository rules and having an overview of what security looks like in terms of the quality of the code across the board definitely is where GitHub Advanced Security can. If you're still not convinced, CISQ, or Consortium for Information and Software Quality, they found that the poor software quality costed US companies approximately $2.08 trillion annually. This is from their 2022 report, and the key contributors to poor software quality was cybercrime, tech debt or technical debt, and software supply chain problems. Now, cybercrime and software supply chain problems could definitely be very easily measured and corrected to an extent using GitHub. Like, for example, if you remove secrets, which potentially could be leaked in the code, or if you remove software code vulnerabilities, you can even inform technical debt work with the required time to complete a task to manage some of the tech debts as well. And last but not least, software supply chain vulnerability. GitHub has options to detect, help you remove software supply chain vulnerability. Now, there are three components to GHAS, GitHub Advanced Security: secret scanning, Dependabot, and code scanning. Now, secret scanning, on face value, it is secrets stored or passed in your repository. It allows you to scan for secrets and raise alerts. It also can take actions from GitHub. Dependabot is an open source vulnerability scanner. It looks for vulnerabilities in open source libraries used in your container, so dependencies or just the libraries that are used by packages which could be vulnerable. It can help raise an alert for it. It can also take an action from GitHub on vulnerabilities that it identifies as well. And third is code scanning. Scans for code vulnerabilities and raises alerts on vulnerabilities that are identified. And you can use GitHub Action Workflow and CodeQL to perform sophisticated code scanning by integrating other security tools in there as well, which are non-GitHub security tools too. Now, what do I do with these GitHub security alerts? Like I've been talking about, GHS can give you alerts on these special things, but what do you do when you get these alerts? Now, as it stands, if the alert makes sense instantly, when you read it, like, yep, I understand that it's basically asking me to remove a secret that I've accidentally put in, or it's asking to resolve a vulnerability by replacing a open source vulnerability, which is potentially a library that you had recently linked from somewhere, you can easily work on that yourself. However, if the alert does not make sense, now whether it's a Dependabot alert or a code scanning alert or a secret scanning alert, the security alerts in your GitHub repository may sometimes require attention, say, from your product owner or manager. So it's worthwhile raising it with them so you can work with the application security teams of your organization to understand the vulnerability and understand what the required action could be. Now, if the alert is not on your own repository, there are processes in most organizations for you to raise alerts for any vulnerability you find in a repository that you don't normally own. So you should be able to inform them privately. Now, there is a private vulnerability reporting feature available in GitHub, but if you have any internal processes that are used perhaps to inform this, you can use that as well. Now, keeping all the excitement aside, we have been talking about GHS, and you may or may not already be using this, but it's worthwhile knowing that depending on whether you are an organization level user on GitHub or you are a personal or individual level user on GitHub, you may have to enable GitHub Advanced Security a different way. Now, the personal one, as it was shown in the lab earlier, in terms of the plans, you have certain capability are available by default for personal accounts on all public repositories. On an organization level, it helps you enable GitHub Advanced Security at an organization level, especially if you work in an organization where any developer can create as many repositories as they want. And instead of manually scanning for what new repositories have been added and what new repositories need to be added to GHS and enabled, you can use the organization level enabling of GHAS to understand how you can quickly apply that to every repository that is within your organization. At an organization level, you can simply go onto the organization, click on settings on the right hand side. This is an example for my Cloud Security Bootcamp organization. And on the settings tab, you should have, within the security column, you should be able to see authentication security, code security, verified and approved domains, and my favorite, especially for the GHAS lab, secrets and variables. Now, once you go on GHS, the personal account, however, is a bit different. You can have a look at the settings and go into code security analysis, and you should be able to access the security features there. However, it is important to know that the personal account does not have access to all GHS features such as authentication security, verified approved domains, secrets, and variables. If you are looking to enable GHAS only on individual repositories, you can do that as well. So not just at an organization level or a personal level, you can go onto a repository that you want to enable GHAS on. Perhaps it's your own personal repository. You can click on settings. Under settings, there is security. You have code security, deploy keys, and secrets variables under the security column. It is important to understand that the level of GitHub security you have would give you you can totally, if you don't have GHS features turned on, you probably would not get any alerting. However, knowing where they are and understanding that, hey, I can just simply go to my repository name, put a /security at the end of it, and you would be able to see the current security posture of what is enabled on your repository from GitHub Security. You can enable it automatically for all new repositories by simply clicking on the button automatically enable. Again, this is under the security settings for the repository. And you would be able to at least have that in such a way that all new repositories moving forward are automatically turned on. However, any existing repositories that were not enabled for GHAS before would have to be retroactively enabled individually. Okay, in this lab, we're going to show you how you can look into what kind of plan you're in. Now, this is me logged into my profile. That's my icon over there. So if I just click on that profile and go, you can simply click on your profile, which should bring you to this page, which is basically what everyone sees usually when they go online. So you can have a look at everything you have on your repositories, 55 projects, packages, and everything else. Now, if I do edit profile, I can edit a lot of the information provided over here, but I'm after information about what kind of packages do I have. So if I go on to here, and I go to settings, and I go billing and plan and usage, I'm currently paying nothing. So I have the GitHub free, proudly. Now I can click on, now this is what it allows me at the moment. I have all these actions. What is not included is also provided as well. And what I can also do is I can go compare all plans, and I can see what can I upgrade to for $4 that I think is Australian, I would say, or US, depending on the currency you're in. And I can get all these features. I only care about the security compliance one because we're on the GHAS class. As I was showing in the slides, code scanning for public repository, secret scanning for public repository, dependency review for public repository, but no security overview for me. No Dependabot alert, and you do get Dependabot alert, but no repository rules. All that required 2FA, audit logging is also available, and role-based access control is also available, and GitHub advisory available for public services. But for the moment, this is how you check whether you have a plan that is a team plan or a pro plan or a free plan or an enterprise plan. Now, if you are on an enterprise plan or a team plan, I would definitely be mindful that you obviously are working with other people as well. So if this is the first time you are looking at Git and making some of these changes, maybe you may not even have access to the builds and plan, most likely because someone else in your organization is managing it for you. So you may not be able to see it. This is my personal account, not my organization account, which is why I can see pretty much billing and plans if I come just to here and go settings. But you may see different things there based on where you are. Okay, now that is a lab that I wanted to show you on how you can check the plans. Let's go back to the slides. Okay, now we're back on the GitHub security. Now we're back on the GitHub. Now we're back on GitHub. Let's just show you how you can look at an individual repository and see what the GHAS level in your personal repository as well as organization repository. So if this is my personal account, I go into my settings, and I can go into code security and analysis, and I can see that I don't have anything automatically turned on at the moment for Dependabot alert, Dependabot security updates, secret scanning as well. I can either disable it or enable it, and I can also have it automatically enabled for, so I can just tick this box and we have enabled for everything. I don't have to hit a save button anywhere. As you can see, the tick box over here is the way for me to know, yep, makes sense. Now I have removed it. Similarly, I can just have, hey, Dependabot. Now, dependency graph is the only thing that I have enabled for all new private repositories. I'm not asking for any vulnerability reporting for that. So I'm going to enable this now, also for private repositories as well. So this is how you see how your GHAS is enabled. I can have it for enable all. It should enable that for everyone. But, this is just one of the ways you see it. Now, another way for you to see this would be if I was in the organization. Now, I have an organization as well. So if I go to organization, Now, as you can see, it shows me I am logged in now as Cloud Security Bootcamp, which is the organization. Now, if I go to settings under this, and then within settings, if I come to security, I have authentication security, which I can sign up for, require two-factor authentication for everyone in the organization. So I can enforce multi-factor authentication. Code security and analysis, I can, as mentioned earlier, I can have this enabled for every new repository that is created inside the organization, but anything old would have to be retroactively fit in. So I don't have any actions or secrets, but you can see Dependabot, all of them have been put in here. Now this is also to verify the domain. Yep. That's pretty much how you would verify what GHAS access you have. Now let's take a bit more, I guess, better example where I can just go into one of my repositories. Let's just go this one. This is a public repository. I can go to security. I can see that I don't have enabled Dependabot alert. I don't have code scanning. I don't have secret scanning because I haven't enabled it. So I don't have alert. However, because Dependabot, these are disabled as well. Code scanning is disabled. Secret scanning is as well. Okay. Now, now that you know, because I have not enabled anything. Now I can just simply come to settings, and I can apply this directly. Oh, this one over here. And now I can just basically enable it individually if I like to, but I'd rather do it at a top level. So I'm going to go to my profile, settings, and I'm going to go under security. So I'm going to say dependency graph. Yes, I want Dependabot alert and Dependabot savings as well. Okay, sweet. So I have that set now. So this is how most people do that as well. So welcome to how it is done in real life. Okay, so this is the repository. I can go to security, and I can see security is enabled, but I have, because this is an existing repository and I just enabled Dependabot for all the new repositories, I have to enable this manually. So I'm going to do enable alerts. I've done that. Yep, I have enabled dependency grid. I'm going to enable the vulnerability reporting for this repository, as you can see. And let's use security updates as well and alerts. All right, so now we have a private vulnerability reporting as well as the dependency graph and Dependabot. So it should start populating information over here, but this time you would notice that if I go to security, my Dependabot alerts are enabled, my private reporting is enabled because I've enabled them now. I can do secret scanning alerts if I just do enable in setting. I thought I had, oh yeah, secret scanning was right at the bottom, so I didn't really see it. So now secret scanning has also been turned on for this particular repository. Now, if it was, it would get appeared under security, and you should be able to see under here if there are any secrets. Now, at the moment, there have not been any secrets found. There has not been any vulnerability or Dependabot. But I know I have a vulnerable repository that I keep for occasions like these when I want to show you something. So if I can name, the challenge is to not remember the name of the repository. It was, I want to say, npm package. So it was, nope, maybe it was node. Nope. Maybe I called it vulnerable. Nope, I did not. That Cloud Security Vulnerabilities is a different repository. This is basically how you identify and slowly make sure that you don't end up having a lot of repositories, because what happens when you're trying to look for just one repository that I know I have, which I just cannot remember the name of for the life of me. But this is what people were doing. Oh, there you go. Cognito V2 demo. That's the one. Now, this is a really old repository that I've had for a while, 6 years ago, as you can see. So I know it has a lot of, there you go. It has already got 7 security alerts for me. I didn't have the secret scanning enabled, so let's just enable that, and maybe that comes up with something as well. Okay, so let's go to security. I had Dependabot alert, I had security advisory. I can see 7 Dependabot alerts. This is what it looks like when you have a Dependabot alert. Now, we're going into a bit more detail about what these are and what you do with them, but this is how you would notice how you to see alerts within a repository. Now, this is at the moment if I go back to code, this is a public repository. However, we want a private repository as well. What can we do with a private repository? So I'm going to go customize repositories. I want it to be type is private. I have one private collection. And if I go in here, if I go choose security, if you notice, I only have Dependabot because that's what my plan allows me for. So that's all I have. I do not get a lot more features, so I can find out more about how to do code scanning. I can enable alerts, but primarily I can just do Dependabot. If I only have a regular plan, and although I'm allowed to create private repositories, but I don't get a lot of security features for private repositories. That is the end of the lab. Let's continue the lesson. Now, so far we've been talking about security vulnerability, alerting, what to do with it, but we haven't really covered what is a security vulnerability. A security vulnerability is a potential risk to an organization that can be exploited by a malicious attacker to misuse or negatively impact the organization. Notice how I did not say a hacker, because technically, as a security person, I'm respectful of the fact that a hacker could be a good person and also alternatively a bad person as well. But collectively calling every bad person a hacker is probably not fair, which is why the industry uses the word malicious attacker. So anyone who is attacking or looking to impact an organization in a negative way would be a malicious attacker. The way they would do this would be they are exploiting a vulnerability that perhaps exists in the software itself, or where the software is hosted, or it could be misused by anyone who is a legitimate user, or it could be a misuse by anyone who's a legitimate user and potentially an internal threat who just happens to have the right access to the code that they want to maliciously change. There are different kinds of security vulnerabilities depending on where and how you're looking. You can have web-based security vulnerabilities, which are like common examples like XSS, CSRF, SSRF. The open source vulnerabilities, which are vulnerabilities found in libraries that are referenced in libraries used by bigger softwares. And open source vulnerability could be a vulnerability that happens to be publicly listed as a free software or free library for use, and perhaps doesn't have a patched library or patch component which allows for someone to basically take over the software or impact the software negatively. Now, other kinds also could include stored secrets like username, password, or API access tokens, and more. Cloud misconfiguration is another one these days, now that a lot of cloud infrastructure is being produced by infrastructure as code languages stored in GitHub as well. You could have a lot of cloud misconfiguration that could be triggered just from the infrastructure as code. So cloud misconfiguration comes for that as well. Now, 0 day is a unique one where, no one really knows when a 0 day is going to come by. 0 day, but the idea behind 0 day is that no one knew about it before today, hence 0 day. So anyone basically is planning for 0 day is looking at it from a very low likely possibility, because no one really ever knows when a 0 day is going to come out. The final one, which is probably the most common one, a lot of people already know of, viruses and malware. And if you happen to work in an organization, you probably have heard of ransomware, which is very popular these days as well, which has been locking out a lot of machines. Now, All of this could be discovered by doing regular security scanning, which allows for bugs to be discovered so that you can fix them before a misuse can happen. How do you identify what kind of vulnerabilities are there, or what type of vulnerabilities are there in your GitHub at the moment? Now, fortunately, GHAS has services which help you identify secrets, dependencies, and even software security bugs, which is under the security section of each repository. You would find Dependabot code scanning and secret scanning. Now, secret scanning helps you identify secrets, passwords, password access tokens, and any sensitive information which you may classify as a secret with a high entropy, essentially. Your AWS access keys are another great example as well. Now, in terms of dependencies, Dependabot helps you identify security vulnerabilities in open source libraries that are used by the code in your repository. And finally, code scanning helps you identify security vulnerabilities in the code itself, which may be just simply because there is poor code quality used in the repository. Something which would be really helpful is that there are, of course, a lot of vulnerabilities, a lot of software types, a lot of software practices that are followed across the board. So it may be hard to keep up with the vulnerability, what is the finer detail of a vulnerability. Now on the screen, I have an example of vulnerability, which is from the GitHub Advisory Database, which is a list maintained by GitHub for all the security vulnerabilities based on CVEs, which are collected from multiple threat intelligence sources, and in fact also includes GitHub's own vulnerability research for multiple languages so that they can keep their customers informed. Now, this is free for anyone to be using. If you use a URL there, you'll be able to find the advisory yourself and go through all the vulnerabilities that they have discovered and advised their customers on, all 16,796 at the time of the recording, across so many different languages to help understand more about the security vulnerability you have found. Let's talk about GHAS secret scanning. Secret scanning is scanning repository for more than one type of secret using regular expression. By more than one type of secret, I mean it could be a username password, it could be access token, it could be AWS secret keys, and many more. This service from GitHub aims to prevent any company secrets from being accidentally leaked on any of their public or private repository before misuse or potential misuse by a malicious attacker. Now, in terms of location for where secrets are scanned, it is your entire GitHub repository. It is your entire Git history on all branches present in your GitHub repository. The description and comments in issues, title, descriptions, and comments in your open and closed historical issues, pull request, which is still in beta as of Feb 2024, and GitHub discussions as well. Now, to simply turn on secret scanning, you can go under secrets, go for secret scanning, and just simply turn on by clicking on the enable button. GHAS Secret Scanning Partner Program. Now, there are partner programs available from GitHub, which is essentially integration that GitHub has with other product companies to be able to notify you of any of their secrets being leaked on a public or an internal GitHub repository. Now, the partner will provide a regular expression to detect possible secret. Like, for example, there is association with HashiCorp Terraform, AWS, NPM packages, Ruby, and AWS, Amazon, Azure, Google Cloud. In case of an Amazon example, if a user makes a commit or pushes a change, GitHub would run a secret regex pattern based on what the partner has shared. So in this case of, if it was AWS or Amazon Web Services, a cloud service provider, if they were to say all our access keys or secrets are shared in this particular format, GitHub would be able to run a regex pattern on the information being committed by the user to GitHub. They would be able to send a match to verify with the endpoint that is from the partner to determine if the match secret is real. And that is how you can have other extended parties, not just the GitHub secrets, but also potential secrets from popular services that your organization may be working with, to identify any secrets being leaked. How can you use GHAS? Now, you obviously need the GHAS license is required to scan both private and internal repository owned by organization, especially if you are on a GitHub Enterprise Cloud. Now, secret scanning is disabled by default for all repositories, which you can simply enable by clicking the Enable button as a GitHub administrator, either on the repository that you want it to be running on or at an organization level. Now, to enable GHAS secret scanning, once enabled, it runs continuously and can be triggered to run always or when a commit is made to the repository. You can run it as a push protection or a continuous scan. In terms of push protection, a secret is scanned for every commit, and it prevents secrets from appearing into the repository in the first place. So it's more of a prevention-based approach. Continuous scan is more of a detection-based approach where it detects and alerts on any existing secrets that you may have. Now, it does not prevent any new secrets from being added because it's simply scanning for any secrets being present. The full list of current secret patterns can be seen on the documentation for secret scanning, but I would say the balance would be to find between push protection and the continuous scan. Okay, folks, in this part of the lab, we would run secret scanning. Now, I already have a repository, which is a public repository under Cloud Security Bootcamp in GitHub. It's called GHAS example lab files. That's the URL. I'll make this available later on as well. I have given each folder for each of the scanning. In secret scanning, as you can see, I have 3 files. At this point in time, I have secret in all of them for all of those files. And so I've got one there, I've got one here somewhere. But the idea is let's enable secret scanning at an individual repository level and then see how quickly it picks up. So to do that, if I go to settings, I click on code security and analysis. And if I scroll down, there's an option here that says secret scanning. Receive alerts on GitHub for detected secrets, keys, and other tokens. So once I enable this, oh, look at that. Instantly, it picked up 3 files, which is exactly the 3 files I have. So GitHub credential, yeah, so this is where you see the file. And I've got the AWS access, AWS secret access. All right, perfect. So it's picked up the files that I had. I can go into each one of them and I can see, oh, that's the file that I had. And that is the exact thing that's called out in the file. That's the file name. Now I can either close as revoked or used in test, mark it as a false positive. Whatever the action that I decide is the use case here, I can just say it's used in test, not a production code. So it's okay for me to put the code in here and that could be the end of it. But that is basically the lab to enable it. To enable it, go into settings and code security analysis. At the bottom of the page, secret scanning. Now, if you ever enable it and if you see the numbers, that's basically numbers which could include other things as well. In our case, we don't have, I think we only have Dependabot, code scanning, and secret scanning, all 3 enabled. It didn't have any findings for Dependabot or code scanning because I guess all tools are working as expected, so no issues there. So for this, secret scanning, 3 alerts, and you can go into each one of them to investigate. Now, that is the end of this lab. I'll see you in the next class. All right, in the next part of the lab, we will cover how you can exclude directories from secret scanning for alerts. So if I go into any of my repository, let me just come back to my actual profile. Yep, that's my profile. I'm just gonna go to one of my repositories. Let's just say this one. And within this, I want to exclude a few directories. Like for example, I want to exclude the directory for, I need something with a few more directories in there. So let me just find another repository. We've got a few folders so I can actually show you the structure. Repository, I think it's called view. Nope, not that one. I haven't created the folder. Terraform collection. I'm just trying to find a place where, oh, there you go. Okay, so this is one place where I have enabled CloudTrail. I just want to see, do I have any security turned on over here? I only have Dependabot. This is a private repository where it makes sense for me to have a .git ignore file. Now what I'll do is I will add a file. Now for me to exclude, I'm going to add a file, create a new file. And I will put a link. So I will obviously want the file type to be secret_scanning. So I'll just put that in here, which is within the GitHub folder, secret scanning. And now paths to ignore. It could be anything. It could be a PY file or YAML file. I'll just put YAML file for the sake of this. Yep, I think I'm pretty happy with it. So I'm just going to go ahead and do commit change, created, added foobar for not secret scanning. It's important to make it as descriptive as possible in the shortest number of words possible. Probably two opposite ends of what I'm trying to say essentially is that keep it succinct if you can, but it should also be obvious what you're trying to do. So I am clear on what I've done. I've created a folder as well. Now, if I come back onto my tree, you should see .git ignore, the .github file as well. So, which has my secrets file in there as well. So, with that said, that is how you would configure what folders or files to ignore as part of your alerts from showing up on your secret scanning alerts. This is how you would do it. And for you to see any alerts, well, this is a private repository. You would not see it because I don't have a paid version. But if you were to go to any of my public repositories, if you go to security, you should see secret scanning and any open alerts would come over here. All right, that's the end of the secret scanning lab. I'll see you in the next class. Hello. All right, let's go through the lab for understanding how to set notification alerts. I'm going to go back to my Cloud Security Bootcamp, my website repository in there. Now, if you look at watch in this, which is the column that I clicked on right now, at the moment it is set for all activity. Now, I can set it for custom and I can pick security alerts as my reason for what I want to watch for. I click on apply. Once I've applied this, I come into settings. And now over here, as I go through this, I should be able to pick, let's not find the option. Oops, not gonna go in the danger zone. Where is it? I think I'm looking for something called email notification. That's the one, it was right on the left. Now I'm gonna put my super secret password in before anyone else sees it. Okay. So now I can have my email notification for, say, info@kaizentech.com and approved header. Set the approved automatic, approve the message is read only. Now I can just simply do, I don't really want to set the approver header. I can basically say GitHub Security as my approved header. So I know how I can describe them separately. And I go set up notification and voila. Now I should get notification for security alerts. Now this basically means every time I do have a update setting. Yeah, so at this point in time, we have configured the notification to be sent as email. Now, another thing that you have to look out for is under notification, usually if you are on a paid version, unlike myself, which I'm not, you would also see a button for watching as well. I've basically put the notification at the moment that it should get emails. Now, this is going to send me emails of everything as well and not just this. but I can also go to my organization. So if I go to my organization, and I can go into settings for my organization, and if I look at the bottom left, I should have notifications here as well. Oops. Okay. Okay, for a lot of the things I actually need like a GitHub Enterprise. So I might not be able to do the remaining part, but this is how you at least would explore. Sorry. This is how you would explore what you can do with it. Now, you can also grant a team member a way to manage permission or manage these. So we can just simply come in here. I can put my name. Actually, I realize I don't have any team members in there. So, or teams in there. But if you have a team, you can definitely include the team to be able to manage your security alerts as well. That's pretty much what I want to cover on this lab. I'll see you in the next lab. Before we start talking about GitHub Dependabot, the first thing you probably want to know is just how prolific open source projects are. As per the November 2023 report, the State of the Octoverse report from GitHub, it was shared that in 2023, developers made 301 million total contributions onto open source projects across GitHub. Open source are projects or repositories or libraries on the internet that are maintained by someone called maintainers. Now, there are repositories for open source that may be maintained for a while, but may no longer be maintained anymore because either the maintainers have not had the time to go back and look at the open source repositories, or open source libraries itself have had developed some vulnerabilities and there probably was no awareness on how to resolve those vulnerabilities. Now, there could be multiple reasons for why an open source is not being maintained. In GitHub, the dependency graph is a good place to see what open source dependencies are in use in your project. This is a great way for you to identify where you may have dependencies and what may or may not be a security risk. The example on the top is showing you there is a high, or at least two high dependencies, which are high risk. That's why they're marked as high. In the bottom one, there are open source libraries that do not have any security vulnerabilities. So you can totally ignore them and let them continue unless one day they do. Dependency graph by itself is not enough. This is when Dependabot comes in. Now, Dependabot is part of the GitHub Advanced Security. It uses the dependency graph that we spoke about just before to scan and alert on any insecure dependencies. Easiest way to understand dependency is that I guess the example of grocery store is the best one. If you go to a grocery store and if you're trying to buy a bread, if you turn the food around or turn the packaging around, you would notice that there is something called ingredients. And if you go through the ingredients one by one, you can find out which ones you're comfortable with, which ones are organic, which ones are not organic, which ones are chemical, acid, or whatever. Similarly, in the code that people write, a lot of us use libraries, open source projects, and a lot more information that may be helpful for the project to run, but necessarily might not have been created by us. This is where the dependency graph for, hey, this particular file seems to use this particular version of this particular language, which probably has some replications or maybe not, but Dependabot is able to scan on triggers for GitHub action. It can also scan packages as long as they have dependency graph enabled on that repository. The alerts are based on GitHub advisory database entries, which is maintained. And an example of it for the kind of format is shown on the left for the different kinds of package managers that can be available. Now, it is worth noting that you cannot scan an archived repository, and this is not your antivirus, so you can't scan for malwares. Again, I go back to the ingredient example. As long as you care about the ingredients that are like your libraries, files, classes that are being used in your code, that dependency graph should be able to show you for the languages it supports, which I have some called out in the example here. How does one enable Dependabot for your repository? Dependabot is always enabled by default for all public repositories and some private repositories, hence the asterisk. You can enable GitHub Advanced Security dependency scan for all repositories inside an organization. If it's your own private repository, you would have to still enable it. But for all public GitHub repositories, it is enabled by default. Going a bit more deeper into the private repositories, if your repository is private, Dependabot requires you to have an additional GHAS license for you to be able to use Dependabot on your private repositories. Now, this is a good example of how dependency graph is used for creating Dependabot alerts using security updates and the version updates, which you can review. That was a good explanation of what it could look like if it was being used. However, as I mentioned, for dependency review by itself for private repositories, it requires a GHAS license. Now, once you've identified Dependabot alerts, and this can be configured on pull requests, GitHub actions, and other activities that happen, but identifying vulnerability is the first step. Once you've identified vulnerability, the next thing you would want to do is you can look at, hey, is the vulnerability valid or is it a false positive? If it's a false positive, you can ignore the alert. If it's not a false positive, if it's valid, but downgrading to an older version without the vulnerability may be an easy solution that you can quickly do. Perhaps the solution is also could be you may have to upgrade to a newer version. Now, both of these scenarios would require you to work with the development team to understand the implications of upgrading or downgrading a version of a library, as the usage varies per organization, and depending on the software or the library, it may be a crucial part of your production environment. So you simply don't want to have all the upgrades and downgrades happen by yourself. In spite of all of the things I called out, I would share some limitations of Dependabot as well, just to close out this lesson. All alerts need to be reviewed by validating for false positive or actual vulnerabilities. Not all alerts would have a security patch, so Dependabot security update is not a foolproof plan, especially if you don't have a version to upgrade or downgrade to. This is quite common if open source vulnerability is on an open source project that is no longer maintained, and unless someone takes responsibility of maintaining the open source project, you are in a bit of a pickle, or Mexican standoff, whatever the right word would be. Now, there are only limited languages that are supported by Dependabot, so in case your organization uses a language that is not currently supported by Dependabot, you may have to reconsider this option. Last but not least, if you are using a private repository, you are required to have a GHAS license for you to be able to use Dependabot. But for public, it's enabled by default. That's all I wanted to cover for this lesson. I will see you in the next lesson. Okay, so in this lab, we'll talk about enabling Dependabot alerts for public and private repository. By the way, just notice on the top right hand side, you can click on this to have your State of Octoverse report, which I was referring to earlier in terms of how much open source is being used. Okay, to start with, I'm going to find a public repository of mine. I've got this. I think I've got a few, but I'm just going to start with this public one. So just to show you how it's enabled, if I go into security, so security, Dependabot. At the moment, I have it turned on, but I don't have any vulnerabilities. This is what it would look like if it was already enabled. Let's find one where we don't have this enabled. Perhaps over here, we don't have it enabled. Okay, so this is a good one. When you come on to this security tab and you click on Dependabot, you probably would see this as disabled if it hasn't been turned on. Now, there are two ways to turn on Dependabot Alert. Similar to some of the other GitHub Advanced Security features, you can either enable this on both public and private repositories, or you can have this enabled at an organization level. This is a public repository, as I would show you here, because it's public. So I'll go to settings. I come on to code security and analysis. Over here, I can see, okay, so I want to receive alerts for vulnerabilities that affect dependencies, manually generate the Dependabot pull requests. To automatically attempting to pull request or group all security updates to resolve. Allow Dependabot to open pull requests out automatically to keep your dependencies up to date. If you notice the theme over here, now to open pull request, to open pull request, and to open pull request. So any pull request that is open and it has potentially adding a library that has vulnerability onto it, this is how you would do it. Now, I would personally recommend you to just have, my personal favorite is just to enable all of them. But then that depends on how, I guess, what your posture may be. Like, for example, the dependency graph is enabled by default. Now I've just enabled Dependabot Alert. I can also add Dependabot rules as well. We can have my custom rules for how my alerts are going. Now, this is obviously for part 2 of the lab, but for the moment, I'm just going to enable all of these because I definitely want to be notified every time there's a pull request and what I could be doing with it as well. Okay. Version update. So this is what I'm calling out. The Dependabot version update requires you to check the frequency and to blah, 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 where the package manifest are located, and you can get more information from configuration option for Dependabot. This is by default setting it to weekly. If you're okay with that, you can definitely make that change. The file would be saved in .github/Dependabot YAML. If you remember our previous lab on secret scanning, .github is a location where we store for secret scanning as well, the files that need to be ignored. Similarly, in Dependabot, within the .github folder, you can save on what libraries, where the manifest would be, and how often do you want the schedule to run. At the moment, I think this is a bit advanced for this class, so I'm going to ignore that. And I'm going to come back to my security settings. Code security and analysis. I see how I have everything. Now, you can obviously learn more about Dependabot Alert on the page over here. It talks to you how you can configure your repository that Dependabot automatically updates the packages that you use. At the moment, we're just focused on getting the alerts. So I have enabled them. Now I go to security and I go on to Dependabot alerts are enabled now. I can either click on here to save your Dependabot alerts, or I can click on this directly. So it looks like at the moment there are no alerts for this, right? This is good. I don't want to create any alerts, but it's a good thing that there are no alerts. Now let's look at a private repository. So if I go to repositories and let me just find a private one, perhaps I can filter. Yes. All right, this is my private repository. Now this should have, my understanding, Dependabot is disabled. Again, similar process. Now this time, instead of going to settings, I'm going to come over here and click on this repository setting, and I can now enable the same things from here as well. Right, so now that is enabled for my private private repository as well. Now, it's worthwhile noting that there would be some limitation that you will come across in terms of how and when it can be scanned, but at least you're able to use Dependabot by default on your private and public repository, which is a good thing. Now, that was the first part of the lab. Next part is to enable this at an organization level. So I'll go to my organization specifically, and now if I go to settings, and I would go for code security and analysis. Now over here, Dependabot Alert affects your dependencies, automatically enabled for all my repositories, and it is enabled and automatically enabled for all my repositories. You want group? Okay. Now, doing this has enabled it for all my repositories, at least all the new ones that'll come through. And that's from that point onwards, you're doing Dependabot alerts. Okay, in the next part of the lab, we'll talk about some actual vulnerabilities, but this is the first part of the lab. Okay, in this particular part of the lab, we'll talk about vulnerabilities on dependencies that we may have. So for this, I have a repository that I had from before. I'm just going to find the repository quickly. So if I just go into this. Now, it's worthwhile knowing that if you don't have a file that doesn't have an open source, you probably would not find anything on the Dependabot. But I think it was called View, I want to say. Oh, yeah, perfect. So this is a lab that I've maintained with a friend of mine with that we have intentionally kept it vulnerable. In terms of the libraries that are there that are vulnerable, as you can see, there hasn't been any change done for 6-7 years on this particular repository. That has been intentional. So the purpose of this lab is to show you, I can already see 7 alerts on my security. So if I go on to that, Dependabot alerts are enabled. And when I click on Dependabot, I can already see that I have a few high, few moderate vulnerabilities. In total, 7 open. So this is what it would look like. Now, the big question over here, as we were talking, I will be looking at this. As a developer, you have a look at this and you have to understand, okay, hook subject to provoke, what does that really mean? I don't know. But I think what it does mean to me is that this was open 2 months ago. Some of them were open 2 years, 5 years. So this is to show you the fact that 7 years ago when I created the repository, none of these vulnerabilities existed. But 5 years ago, there was one discovered for cross-site scripting on a package in the file that I have for my NPM, which is a web packet bundle analyzer in the package.json file. All of them seem to be on the package.json file. And if I click on any one of them, I can see how I can resolve it, upgrade the web package to fix the Dependabot alert. From going from 3.2.2, I can go from I can change the dependency. And the recommendation is version of prior to are vulnerable. Packages use string without blah, blah, blah. Okay, so patched version is 3.3.2. So instead of going for less than, was that what it is? Oh yeah, so I need to go for greater than or equal to 3.2 instead of less than 3.2. So that's if I change that update and if I would put a pull request in, and that should be able to resolve the vulnerability. Now, as you can see, then 4 years later, 2 years later, 5 months ago, 6 years ago, 2 years ago, 2 months ago. So the important parts over here is to do the same thing. So if I go to each vulnerability and identify, okay, am I using this package? It is saying that my package.json file has HOIC, if I pronounce that right, as set to 6.1.3, but there is no patch available. Now, as an organization, I have to make a choice where it looks like the vulnerability, the severity is high, and am I someone who's going to click on this package or JSON file? If I just do a command F, I can already see, yep, I am using it, and I'm using a version 5.0.3, which is vulnerable, and it affects every version which is less than 6.1.3. Now, I can make a choice and go, the issue has been patched in version 9.0.3. I can go all the way there or backport it to 8.5.1. This is obviously a bigger change. For people who are developers here, probably understand it. Now that I have been using version 5 in my, where was it? 5.0.3, moving from 5.0.3 to 8.5.1 or even 9.x, that's a big change for people who have been in the development background would understand this. So this requires a lot more understanding of what other options are there, how would we change it, would changing the HOIC file, would that affect anything else we have in the code? So there's a lot more that needs to go into this as well as you understand the Dependabot alerts. Now, you probably want to send email notifications for this as well. So you would have email notification, and you can even set a notification for how and where that should be going. Or in terms of, I guess, getting an email rather than going into this every single time. And you can also have these auto triage feature, which is still in beta at the moment. So I'm not going to experiment on this lab, but you can definitely, if by the time you come to this recording, it's already enabled, you may want to give that a shot where Dependabot opens a pull request and ignores false positive and snooze alerts as well. But this is how you would start and investigate any alert that you would get on Dependabot, where after that, as a business, you'll make the call for, are we going to fix this vulnerability, create a pull request, and update the package.json file, which is the vulnerable, which carries the vulnerable open source package, or are we just going to leave it? I'll leave that choice to you, but that is the end of the lab. Code scanning is a service from GitHub which allows you to use CodeQL, which is a proprietary service from GitHub, or a code analysis engine, if that's what you prefer. If that's easy to understand. Basically, code scanning helps you analyze the code in the GitHub repository to find security vulnerabilities and coding errors. Code scanning is available for all public repositories and private repositories owned by organization, as long as you have GitHub Advanced Security enabled for the private repository. Code scanning needs to be enabled for public repositories as well. And depending on whether you are happy with the default settings of CodeQL, you are also welcome to use third-party tools by GitHub through the integration they have provided for the languages they support. Code scanning uses GitHub Action for workflow, especially if you are forking a repository. You would find that you won't be able to enable code scanning without having GitHub Actions enabled, because when you enable code scanning, it runs a set of workflows which is in GitHub Actions, which is required for code scanning to work. Now, similar to secret scanning and code scanning, the languages being supported, and once enabled, it fairly quickly goes through the code repository, even if you go for the default option. But you can also go for the advanced option. But I wanted to call it out that if you are forking a repository, so it's not as simple as code scanning being enabled. And we'll go through a lab later on in this lesson where we'll help you enable the code scanning capability. Now, to enable code scanning, when you simply click on enable, you get this default configuration if you go for the default option by simply going into your repository, clicking on code security and analysis, and on the right hand side in the middle you'll see CodeQL analysis setup, and you just pick the default option. Once you pick the default option, you should see the window on the left, and you simply hit enable CodeQL. Now, it doesn't happen instantly. It does take a few minutes for CodeQL to enable, so you'll see the setting up screen, and you would need to wait a few minutes before it actually gets enabled. You would get to see this in the lab at the end of this lesson, but for now, this is how you enable CodeQL. Now, as I mentioned, there are two options. When you click on the setup option for your CodeQL analysis, you can either use the default option or you can use the advanced option. If you use the advanced option, you're basically saying you're going to write a configuration file in YAML, and you would not be using the default options provided by GitHub. You would be using your own. So that's the difference between a default and an advanced. For the purpose of simplicity, and if you're learning, I would say focus on the default. It gives you the GitHub recommended option to start off with. But if you are an advanced user, definitely go ahead and write your own CodeQL configuration. Now, it is possible to use CodeQL with third party, as I called out earlier. The simple workflow could be if you have Microsoft Defender, if you have a container image being created, or any third-party integration that is available in the GitHub marketplace for the category of security, they would all be available for you to use in the third-party tool as integration for CodeQL. Now, the list keeps changing. At the time of the screenshot, when I clicked on Explore Workflow after enabling CodeQL, I only got 74 workflow options for security. And again, these are all going to use GitHub Actions, but this may be different if you see it on your GitHub profile, depending on when you're watching this course. It's worthwhile calling out, why is code scanning important? in the context of software development lifecycle. Now, software development lifecycle goes through code where you actually write the code, you build the code, you test the code, and then you release and deploy the code. Now, you can run code scanning on every pull request, which I would not recommend. In fact, GitHub doesn't recommend either. GitHub, in fact, recommends the use of on pull request path as a way, or even request path ignore as a way to only scan for files which you want to include, and use the pull request path ignore to exclude or not initiate any code scanning for the files that you have called out. But if you know the location of what files you want to be scanned for code scanning, then use the path variable. But if you don't want to include certain files, use the paths ignore variable. Actions on repository can have a set of actions that can occur on pre-merge, pull request, or push request. So every stage of the software development lifecycle, if you're looking to integrate not just code scanning but security, these options are available. Now, to run a code scanning, it is a trigger. Now, the trigger could be multiple. The trigger could also be from a push to the repository, where you're pushing a line of code into the repository, or someone has asked or triggered a pull request, which is triggered in a manner that it identifies that there is potential vulnerable code in there. Or you can run it on a schedule basis. The default is weekly, provided by GitHub. Now, code scanning configuration would allow you to change the code scanning schedule as well as the event, but that is also the advanced option. If you decide to go the advanced path of writing your own YAML, then that is definitely the path you can take. Now, prevention is better than cure, as someone said. So if you are able to apply this preventatively, or at an organization level enable it so that people have the option to do code scanning, you may actually have a shot of enabling code scanning made available for everyone. Welcome to the code scanning lab. In this lab, I already have created an example file. If you are on GitHub, you can go to github.com/code cloud security bootcamp. I have a repository that I've created over here, which is public, so you should be able to access it. And I can put this in there as well. But essentially, it's just cloud security bootcamp, and within that, GHAS example lab files, which is the GitHub Advanced Security. I've created each folder for each of the different types of advanced security you can do. In this particular lab, we're talking about code scanning. So let's do code scanning. As you can see, there's one file in here. I haven't added a lot. So the first thing you need to do is go into settings, and the lab will talk about how do you enable GitHub code scanning. To do that, in your repository, you can go to settings, you can go into code security. I don't have anything enabled. As you can see, Dependabot, none of them are available. Code scanning is available, which is under, again, code security analysis. Under the settings of your repository, if you go into code security and analysis by clicking on code security analysis, and if you scroll down, you should see a question said CodeQL analysis. Now, as I mentioned in the lesson, code scanning uses CodeQL. So to enable that, you need to click on setup default. I would show you advanced in another example, but for now, we'll just use the default option. It does take a few minutes. It has recognized that the file that I have is a Python file in this repository. It is important to know that CodeQL can only work against languages that that GitHub allows for. In this case, I picked one that it does. I have picked the on push and pull request to protected branch as well as the main. I'm happy with that, and it would do a weekly schedule. Now I'll enable this. I can edit this if I want, but I'm happy with this, so I'm just not gonna change any of this. I'm just gonna go, okay, I'm gonna say enable. Now, it does take a few minutes, and if you're curious as to if it's setting up over here, if you're curious as to what it's doing, if you come to actions, you should start seeing over here. Basically, as I've called out in the lab as well, it uses GitHub Actions to do it, and because it's a public repository, it is going to queue up a set of workflows in GitHub in GitHub Actions. And at the moment, I've figured out the workflow for CodeQL setup. It takes a few minutes. Once it completes, we can continue the lab. So I'm just gonna pause the video and come back. Or I might just continue the recording and it might just, or what I might do is I might just fast forward it. There would be different parts to it as CodeQL is added and enabled, just for you to know. Okay, looks like CodeQL is set up now. So if I go back to settings and code security analysis, okay, I can see the file. Last scan was 1 minute ago. Now if I go to security, and I should see code scanning is enabled. And if I can click over here for view alerts. It doesn't have any alerts. It hasn't found anything on this yet. It's a good thing. So that means we are safe for now. But if I go into code scanning, so it doesn't look like there's a lot. I would have thought this would be picked up, but this is a good example where it is not being picked up. But to make it work, what we can do is there's a I have this repository that I'm gonna fork. Okay, so while it's forking, this is a website, or this is a juice shop, is by an OWASP project, which, if you don't know, is Open Web Application Security Project. They have a lot of these vulnerable applications that you can use to identify if you have any vulnerabilities. So to continue to show you how it can work, I'm gonna click on actions because I understand my workflow. Go ahead, blah blah. I need to do. So if I go to settings for this and I click on code security analysis, if I find my code scanning, as you can see, it would not be enabled because I don't have GitHub Actions. To enable that, I can go into actions. I understand my workflow and go ahead. I clicked on that green button that appeared. Now it takes only a few seconds. Now I go back. So, okay. Now that I've enabled GitHub Actions, I can go into settings. And if I go into code security and analysis on the left, I should see the CodeQL analysis. Now to enable this for a repository, the easiest thing to do is to simply click on setup and use the default option. You can use, it has recognized there is JavaScript files in here and Python files in here. So we'll do enable. And if you want to see the set of actions that are taking place, either you can just stop on this page and see what's going on and it would not show you anything. Or you can go to Actions tab and you can see how it's set up. We'll fast forward the video to the point where it enables it, but this is how you would enable CodeQL or code scanning. Another thing you can do while this comes up, so I might open a new tab and I can show you how it works in an organization as well. So if I go into, this is my organization, I can go into settings, and within settings, I have code security, and I can use global settings under code security. And as you can see, I can configure it. I can call it out, recommend the extended query suite for repositories, enabling default. The extended query includes the default suite plus lower severity issues. So once I enable that, it would be enabled for extending queries to default suite. However, it doesn't mean it automatically enables it for all the repositories. However, you can at least configure the recommendation for query suites to happen. That is a global setting. Now, there is a beta feature as well, where you can see that I have two, and I can apply to all repositories configuration for code security. I can even configure, I can actually say, hey, I'm going to select these, and I'm going to apply configuration for GitHub recommended ones. So I can just go GitHub recommended, two public repositories. I want it to be as default for newly created repositories. I want only public, private, and internal, all repositories. I want the code security configuration to be applied for all repositories. Once I apply that, and it should kick off, and it now has GitHub recommended. Okay, so that is how you enable on a organization level. If you, however, were on a personal account, so I'm just going to go to my personal account. If I just click on your profile, so this is my personal account. I can go into any of the packages. I think I have the same package here as well, but let me just go to repositories. And I have one called Juice Shop over here as well, which I've basically forked earlier. As you can see, I had enabled code scanning before, so I have a lot of alerts already on for code scanning on everything is found. That is the name of the file that it is looking at. So it has found a lot of the code scanning vulnerabilities. This is what it looks like. I can look into the warning, but for the time being, what I would do is the same thing. Maybe let me show you a file, which I'll show you a file where I don't have it enabled. So if I come back to the personal page, I can pick any repository. Let's just say I pick cloud security vulnerabilities. Now to enable to enable scanning or code scanning on this, if you notice, I don't have code scanning enabled because I clicked on security and it showed that it's not enabled. So if I go to settings and I click on code security and analysis, and I come down, I can see that CodeQL analysis is available. I can click on setup. Same thing that you see at an organization repository. It would not be any different when it's a personal account. So you can do that. And if you want, you can click on edit and you can have a look at these, but I don't believe you can change them unless you want to extend the default suite in any other way. But simply clicking on enable CodeQL should enable that for this repository. Now it's worthwhile noting I have a plenty of JSON, nothing really sophisticated over here. It's just a README file. I'm not expecting it to do a lot of things here, but I should see the same if I click on actions. I should be able to see that I don't have much in there apart from I have all these services enabled. And to always confirm if you have services enabled, click on security for any repository and you should be able to see what services are enabled. That's pretty much it. That's what I want to cover in terms of enabling code scanning for repositories. And that's the end of this chapter. I'll see you in the class. Using CodeQL to do code scanning. This is how you enable code scanning by going to settings, code security and analysis, CodeQL analysis, and setup. Now for this, we are picking the default option for now, but we will talk about advanced in a bit in the same module. This is how you would enable it for an individual repository, but you can also enable that for an organization in GitHub as well. If you are working for an enterprise, you probably already have third-party tools that you may be using already that are already scanning code, doing vulnerability scanning, and a lot more. Fortunately, GitHub Advanced Security also allows you to import alerts from third-party code scan results in the form of SARIF files, that is static analysis results interchange format. It's a mouthful, but SARIF, those who did not get the full thing. So SARIF files are basically alerts that have been captured in a third-party scan of the same code that is in your repository right now. So SARIF files, now you can upload these files using Code Scanning API, CodeQL CLI, or even GitHub Actions. However, worthwhile calling out, if you do use GitHub Actions method, it still requires the use of GitHub Actions workflow using the upload SARIF action with the SARIF file as the input. And for those of you who probably know GitHub Actions in detail, you probably understand this would be a step inside a GitHub Actions file. Here I have in the screenshot an example of what a SARIF file looks like. It has configuration. This is from a JavaScript TypeScript SARIF file that I downloaded from GitHub. The first column is configuration, second as the rule source, and third as the unique identifier, and fourth as the alert. Now, this is a standard format that is recommended to be used if you're importing third-party scan results into GitHub so that you can see them in code scanning in the way it should be seen. Now, in case you're wondering what happens when you click on CodeQL enable, it basically runs a set of GitHub actions in the background, and we'll show this in the lab as well. You can even have workflow files created as YAML format in the .github/workflow/CodeQL.yaml. Now, the name of the file is not important. You can call it anything you like, but you can refer to it in the action that should happen when code scanning is enabled, and it would understand, oh, this is the file that I need to use. Now, code scanning obviously is, once enabled, kicks off GitHub Actions by itself. First one would be to install CodeQL, and second one, if you have a schedule, it would set up a schedule for a periodic scan to run of code scanning for the repository that you have in front of it. Now, if you choose to go down the custom configuration path, that is, instead of using default configuration, if you choose custom configuration, in this example, I'm using a CodeQL.yaml file. That's the file would define what configuration would be used for scanning code in that repository. Another thing that also happens automatically is that it detects what language is being used for code scanning. CodeQL is pretty smart like that. They obviously support a certain number of languages, and they have detection capability for understanding that the repository that they're working on has a certain kind of language, and CodeQL is pretty smart to detect it. However, you are able to add Query Suite into it as well. Now, more on Query Suite later to enhance your findings. Now that we understand what happens when code scanning is enabled, it is important to know that code scanning essentially is running a CodeQL analysis engine in the background, which is why GitHub Actions starts off by installing CodeQL. The analysis engine first creates a database using information from the code repository, and the database itself is a single directory created to analyze relational data, copied source file, and a language-specific database schema that specifies a mutual relationship in the data, which goes back to what I was referring to, that it automatically detects what language is in use. That's how it will be able to work on it. Once a database is created, CodeQL can run queries against that CodeQL database. For CodeQL queries, you need QL, or query language, which is object-oriented query language. And the language is used to run against the CodeQL database, which has the information on the code database. Now let's deep dive into CodeQL. GitHub CodeQL is a semantic code analysis engine that's going to query data as though it were data. In this case, it would be a CodeQL database, which would have the relational context of the source code of all the files that are in the repository. CodeQL is not just to find information that is relevant for a non-security activity. You can also use it for identifying vulnerabilities. CodeQL files usually have a .ql extension, and there are usually two types of queries. One is alert-based, and the second one is path-based. An alert-based highlights the issues in a specific location in your code. That's what would raise an alert. A path query would describe the flow of information between a source and a link to your code. The screen also has an example of a CodeQL query. If you notice the fourth line, or even if you just look at the format, and I'm going to talk a bit more about the format, it does look like a database query. It has import from, where, select. Dive a bit more deeper into this. Essentially, import would be defining the library or modules that you want to import into the query. Now, this is your CodeQL classes. For people who are used to programming, they might understand this already, but I would say the easiest way to understand this is that first, it starts off by having a lot of comments. It helps you understand what each information needs to be. The very first section is a commented section for query metadata. That is if you have any custom queries that you wanted to include in your CodeQL execution. Second line is for import, where you can import different CodeQL libraries or modules by calling them out in your CodeQL file as you create them. Now, this could also be CodeQL classes and predicates as well. Now, there are other variables you can also use in a code query. For example, you can use name to define a label for the query you're trying to create. Description could be description in detail on what the query would be related to. The kind, as I mentioned earlier, there are two kinds, either alert or path, and the prompt for that would be either problem or path problem. Problem severity defines the level of severity, error, warning, or note. Precision defines the priority of the problem. Is this a very high or a medium or a low risk? ID is a unique identifier, and tags are labels you can attach to identify the query easily. So let's put this in practice. If I had the above, which is if error, handle the error as a comment, the if expression in this Ruby is a bit redundant because there is nothing really going on if I use the if statement. But what if I wrote it the way that it is at the bottom? I first import the Ruby abstract syntax tree, which is AST file for CodeQL. After that, I use the if express. Now it calls if express, which is from that ruby.ast file that I imported just before. Now where not exist, if express.get then is basically where the content of the if then expression does not exist. And select is as I said earlier, is a filter that you apply for what you want the result to be filtered by. So in this case, it would be a human readable message of the problem based on this if expression is redundant. That is, if it matches the criteria, it is going to display the result. That was just a single query, but you could also have something called a query suite, which is basically grouping of code queries that run against your code, but a grouping of it, not just one or two, but you can have as many that make sense and are available in your code query suite. GitHub also has a built-in code suite, which is set as default, but you can also do security extended version to it as well. Now, queries included in the build suite also are supported by languages like C, C++, C#, Go, Java, Kotlin queries, Java and TypeScript, which is the example I showed you earlier, Python queries, which is the lab we will be seeing soon, JavaScript is also in the lab, Ruby queries for CodeQL analysis, Swift queries for people who are the Apple iPhone people writing codes for apps. That would be Swift queries for CodeQL analysis. The built-in queries for the query suite can be viewed in your GitHub documentation, which is easy to find. This specific one is for Python analysis. You can see the first one being accepting unknown SSH host keys when using Paramiko. Arbitrary file write during tar file extraction. Badged HTML filtering regex. All of these are definitely things you can call out, as well as things that are helpful for you to quickly understand what the query would relate to. There's also CodeQL Packs. Now, CodeQL Packs are consisting of not just CodeQL queries, libraries, which you can use the pack to share, create, and use it as a dependency as well. And in your metadata, if you'd like to include that in there as well. A CodeQL pack contains queries, library files, query suites, metadata. But there are three kinds of CodeQL packs. For example, you have query pack, library pack, and the model pack. Query pack is a precompiled query, which was what we were looking at just in the previous slide. Library pack is to be used with a query pack, but they do not contain any query. These queries are not compiled separately, but these could be custom ones that you would have created yourself. Model packs used to expand code scanning to recognize libraries and frameworks that are not supported by default. Like, for example, if you may have an organization-specific CodeQL query that you would want to include, you can use this for that. Now that we understand the anatomy of CodeQL and what happens when CodeQL is running, it is worthwhile knowing once you've enabled code scanning, you can use two ways to run CodeQL code scanning. One is code scanning workflow, where it's a default. You are either using CodeQL packs or CodeQL queries to inform your CodeQL analysis engine on what tests to run. The second option is your custom configuration file, which is if you have used the advanced option for setting up CodeQL, you could use that as a way to start building up CodeQL packs as well as CodeQL queries that you can be adding to the scan. GitHub has a registry of standard CodeQL packs it maintains on GitHub, which also reminds me that you can use CodeQL to scan containers as well, either using third-party tools or simply using existing packages available in your CodeQL. Now, different kind of packages do exist. You can install standard packages like your CodeQL CPP, C#, Go, Java, JavaScript, Python, and Ruby as well, which can be automatic downloaded if not downloaded already. Worthwhile knowing that if you have both, that is, if you already have a workflow defined, but you also define queries in your configuration file, the workflow files queries would be the only ones used unless you add the plus symbol to include the configuration file queries when the workflow kicks off. More information more advanced information on this can be found on the GitHub website. Now, so far we've been talking about how to enable code scanning. We've spoke about how to use CodeQL and what really happens when you start it and what kind of rules you can have. Now, we can go a lot more deeper into it, and I would highly encourage you to do that. But GitHub Advanced Security is a bit more than just configuration files. It's also about all these alerts that you're going to get. Perhaps could be over 100 alerts when you run it on a file. All these alerts may appear under your security tab for your repository. And please don't send this as it is to your development team or whoever is supposed to be responsible for looking after the results of vulnerable instances in your code repository. Instead, I would encourage you to have this workflow for your alerts. First one would be someone in your team is triaging whether the code scan alerts are genuinely a false positive, that is, they are not true, or are they a true positive, which means they are true and someone needs to investigate this further because you have identified it is a vulnerability and it can be exploited. Now, the step 2 on this workflow would be, now that you've identified that it's a true positive, your organization most likely has a security risk matrix to identify, hey, what do you do with high, medium, or low rating of risk for security, and specifically technical risk of security? And you would be expected to follow the appropriate procedure to take steps towards resolving the vulnerability. That is, if it makes sense for the identified risk rating. At this point in time, you are engaging with the development team, the product management team, and anyone else who probably is supposed to be in the loop for them to be aware of a vulnerability being identified, especially if it's a very high or a high vulnerability. And the rating may change from organization to organization, but the processes at least on a very, very high level are very similar. The steps to take after you've identified a true positive may vary from an organization as well. Okay, welcome to the lab for Module 5. We can talk about CodeQL. To start off with, I am in my Cloud Security Bootcamp GitHub repository. I only have one, which is an example lab file that I created. I had that enabled so just for me to see how I have enabled and what I have enabled for security. I can simply click on the security tab on the top, and clicking on that, which has a number 3 next to it, I can simply go and see, okay, my Dependabot alert is enabled, my code scanning alert is enabled, and my scanning for secrets is also enabled. But it looks like I only have 3 secrets, which is probably a bad thing, but still. But I don't have any Dependabot vulnerability. I don't have any code scanning vulnerability. Now, I'll be honest, I'm not the best programmer in the world. But one thing I know for sure is I at least know how to find vulnerable code, which I can fix. So in this scenario, I have an example for you that I've looked into before. There's a very popular organization called OWASP. And what I'll do is I will copy that repository over here. So this is called Juice Shop, which is a repository from OWASP. Juice Shop. OWASP is a open source vulnerability management project. They stand for Open Web Application Security Project, and the intent behind OWASP is the most modern, sophisticated, insecure web application. That's how they describe it, because the intent behind creating this repository is for people like you and me, for us to learn on how we can do security and what are some of the bad things we can look at. But in our specific scenario, we can use this to test out the GitHub Advanced Security code scanning option. So for this, I would do a fork. That is, I would create a copy of this for myself. I can do that by clicking on the fork button. You can click on the drop down if you like, and you can say where you want to create it. I already have a fork on my personal, but I want to create a new one. So I'll just click on create a new one, and I can choose the owner to be my organization. Now, there is no other repository under Cloud Security Bootcamp with that name, so that's what would stick. And I can probably say number 2, so just it's a bit different. And I can copy the master branch only. I don't really want to have any of the sub branches. If I've done all of that, I can just click on the green button, which is create fork. Now, it does take a few seconds, sometimes a few minutes, but well, it only take a few seconds, but that is how it would be. And now if you notice, this is under Cloud Security Bootcamp. If you see where my mouse is highlighted, it is a public repository called Juice Shop under Cloud Security Bootcamp, and it's forked from the actual original repository. Now, we're not done yet. We obviously only have a vulnerable repository that I have just brought into my GitHub organization. I don't really know yet how to learn code scanning. So what I'll do is I'll go and enable this first. So if I go to settings on the top right, and code security and analysis. Now, I've mentioned this before, but I'll call it again. Because this is a fork, and because we just learned from the class that CodeQL code scanning requires GitHub Actions, we would not be able to do anything just yet. So let me show you why. If I go to code security analysis, and if I see, look at that, it's not enabled because GitHub Action is not available. Now I can either click on enable it here, or I can submit a code scanning result, which is the SARIF file. I can click on that, and basically talks about how you can upload a SARIF file using the 3 options that are available. But I'm going to keep it simple for you guys. So I'm just going to simply click on enable it. Now it's going to ask me, hey, you understand? You can either look at the workflow directly yourself, but you can look at it after as well. But you can say, I understand my workflow, go ahead and enable them, because we are smart people. So I'm going to click on the green button. All right, now we are under the Actions tab, which is your GitHub Actions tab. Workflow, and as we just learned in the class, workflow is where you define all the automated action that the GitHub action is about to take. We're obviously keen on the CodeQL scan. It hasn't run yet, so that's why you don't see it, but you can see the file that will be triggered when CodeQL is enabled. So if I click on that, you would be able to see the file, which is the workflow and code analysis file. This is the file that would run. This is what a CodeQL custom would look like, custom advanced one look like. The easiest way to understand this, this is a GitHub expert. This is a GitHub action file more than a CodeQL file. So the simple way to understand this, if you've never seen CodeQL, is that this would run on push as well as a pull request. This also calls out that, hey, when you are running a job called analyze, run the analyze function, run it on an Ubuntu container. It should have action and content as the read, and the security event should be written down. It should be on JavaScript and TypeScript language. Now, once it's defined what the analysis directory database container would be, you can then look at this number of steps. Each name is the step that would be taken. That's name, code checkout repository, initialize CodeQL, and then auto build, perform CodeQL analysis. Now, all of that is triggering a GitHub/QL action, and it's already called out the file and the checkout it needs to run. That's the simplest example of a CodeQL scan. Now that we have done all of this, you should come back onto security, which is in the top. If I click on that, you would notice that Dependabot was already set up, so it has identified that I have 13 vulnerabilities in my Dependabot, which I'm going to ignore for now because we are focused on code scanning. At the moment, it's not, if I click on code scanning, it's not configured. But instead of configuring it here, let me just take you to settings and code security and analysis. If you scroll down, you should see code scanning. And now look at that. It looks a bit different, doesn't it? Now, I have spoken about the third-party tools. I will talk about it again. But for now, let's just use setup and default. I'm happy with this. It's identified that I have Python as well as JavaScript in my repository. It has extended some query suites as well. And I have it on push and pull. It would run on a weekly schedule. Now, I can edit this if I want, but I don't really want to. So I'm just going to go enable CodeQL. Now, once this is starting to set up, you should see assigned repository settings saved. It may take a while because code will full scan of the repository. Now, if you look at the bottom, it says it's setting up. So CodeQL is still setting up. If you want to see what it's about, you can go to the Actions tab, which is on the top. And you can see it's running a CodeQL setup. Now, if you give it a few minutes, it should run the CodeQL. And hopefully, because we definitely have vulnerable code in here, the security number should update from 13 to a larger number with a bit more than just my dependency bot alert. But while it's doing that, I wanted to show you what third-party tools you can use as well. Now, if I go into settings, I come back over here, and if I click on the explore workflow, there are 74 code scanning workflows that are available for us to use. The best one obviously being the CodeQL analysis from GitHub itself, if you just want to stick to that. But there are a lot of third parties that you can also use for code scanning. There are Microsoft products, non-Microsoft products, a lot of them basically. You can keep going through all of them. Pick the one that your organization has already gotten an allegiance with or probably already working with. They also, as you can see, this is by GitHub Actions as well. I would probably only go for the one that you recognize. There's one from Meta for a Python compliance one. I would only look at the ones that you are comfortable to run in your organization and are by, I guess, for lack of a better word, identities that you trust or organizations that you trust. I think at this point in time, I'm only accepting GitHub Actions as the owners or Microsoft as the owner. That's probably trustworthy for me. I can probably use those, Microsoft Corporation, quite a few of them, but depending on the purpose, you can search the one that makes the most sense for you and just use that. So you can integrate that. To integrate that, let's just do configure. If you click on configure, it takes you to the CodeQL file. Now, this is exactly what we spoke about in the class. We gave it the name. When do we want it? On what branches do we want it? How often should the schedule run for that workflow? What should the analyzed job have? Whether the security event should be written. You should fetch internal or private CodeQL packs. The strategy. And then we are on to the steps. This is exactly what I was showing you in the previous one. If you notice over here, you can first initialize CodeQL. That's what's going to kick off. It's going to identify the language from its existing matrix and also the build. And if the build is manual, it's going to run a shell command. And the shell command is going to basically, if you are manual, make bootstrap, make release, and exit. And the rest of the analysis would happen at the same time as well. That's when it would use the perform code analysis. Now, this is how CodeQL itself runs, which is what we were seeing over here. If I just refresh this page, sorry, just one second. Oops, not that I wanted to do that. It is still setting up. So if I come back to the action, it can still set up, still in progress. Give it a few minutes, and it should just basically work after that. So I'm going to pause the video, and then I'll come back. Okay, okay, I'm back, and looks like my CodeQL is set up. It's finished. So we go into CodeQL. I can see that there was a bit of an error, as you can see over here, real-time shooting of the error. For some reason, it was not able to make a connection and was timed out, but it still finished. So I'm not going to question it for now because it was a success. But let's just quickly see what it did. So if I click on Analyze, I can see it did a perform. It did a setup. So if I clicking on this, it we can see what it did exactly what was called out in the file. It basically had a checkout repository with it basically called out the image, it called out the GitHub token to be used, and as it went through it, it initialized it, set up CodeQL, and perform post initialize. You can actually see the entire job over here. The more important thing over here is the output, cleaning up orphan, evaluate. There are no errors over here, which is a good thing. So it definitely worked. So did analyzing the Python files, and it did a great job of looking at it. And it did some adjusting required. Nope, not required. Okay. So now if you look on the top, you probably will notice that, hey, there are 132 things that have been wrong, which is probably not a bad, well, it is a bad thing. As I was saying in my example, there are 119 incorrect, or there are 119 vulnerable files potentially if impacting this particular code repository. It is what it is meant to be. So if you see more, don't be afraid, because it just could be that when you're running this code scan against the version of Juice Shop that you're running, there may have been more vulnerabilities that have been discovered. But the important thing over here is I have it enabled, and now I can see my code scanning result. As you would have noticed, it does take a few minutes even after it's turned on for it to finish a full scan. But this is what I am facing at this point in time. I have 119 open issues. Now, it is important to understand the criticality. So if I click on severity, you would see there's low, medium, high, and critical. This is what I was referring to in the class, that critical means that it is really critical, that this should be looked at today, right now. And it may be different for different organizations, but I would still, looking at the critical that we have, if I just filter this by critical, you would notice that there is a lot of critical right there, right? So I'm just gonna go, okay, I can't clue everything here, so I'm gonna sort. What's the best way to approach this? I have 119 CodeQL, 19 of them out of the 119 have been found to be critical. So I would, as a first step, if I was most organization, I would just go through these. Let's take the first one. Now, remember, we are doing it based on the severity. We're not doing it based on, what looks the most interesting. It is very important for you to know that you're responding based on the criticality of the severity of the alert raised over here. Critical being the most important, followed by high, followed by medium, followed by low. And when there are 119, the last thing you want to do is send it all to your developers, because as we saw in the class, this could have a lot of false positive in there as well. So let's investigate the first one just for, actually, how about we do code injection? That probably is a more enticing one, or even a hard-coded credential as well. That could be something people should look at. So if I click on hard-coded credential, oh, look at that. It has a bearer token right there, which it definitely looks like a password. So I probably would, this is definitely, in my opinion, it is a critical, because I can see it's a code. Now, me as a security analyst who's reviewing this, I can either copy out this entire token, and if I have an internal validator for OAuth tokens or just JOT tokens, I can simply use that to identify, is this coded, is this key still vulnerable, or is it still active? And if it is, I need to ask the developer responsible for this repository to replace them and probably remove them as well, especially if this is a public repository, which in my case it is. What about another one? Let's just go code injection, which we were looking at just slightly. This is based on the fact that I am not filtering the input that I'm taking from the user. That's where it's calling out that, hey, by the way, if you're directly evaluating user input, code without properly sanitizing the input first allows an attacker's arbitrary code execution. So I could literally send it some kind of an injection attack, and it would be interpreting it and running that instead of running the actual code. Now, these are some of the examples, and as you would have seen in the class, we spoke about how these are to be triaged. Don't send all of them to the developers in one go. Make sure you at least have a look at whether they are false positive or true positives. Now, if you notice, it's reported a bit of a warning for me. So if I go into this, I can see that the status of the tool. Now, there's two ways to come here. You can either click on that button, or you can go back on tools, go back one more. You can see over here, it says add tool and it says tools. So if you press on tools, you should see I only have one tool called CodeQL, and it last ran 9 minutes ago. It is looking for, it has looked at 571 that were TypeScript, 3 files that were Python, and 14 files that were JavaScript. So it's primarily a TypeScript file or TypeScript repository. I can click on this and view the setup. I can go, okay, it is the CodeQL that I had enabled. It is set for default. Nothing to see there. I can click on view configuration. I can see when it was last configured, and look at that. I'm actually on the same screen that I was on before. Now, if this was important for me when it last ran the scan and I found that it could not process a file due to a syntax error, a parse error for syntax was to... Now, I have two options. Either this is a legit, like I can go into the last scan and look at where it was, where it found, what it found, and look at that, all of that. And there was one particular place, it was called out as, it should not be right. Okay, so all of these looks like name changes that need to happen. And yeah, that has not been called out. I'm gonna ignore the white space for now. Yeah, so it's basically showing us, hey, this is a change that we can commit if we want by fixing broken links, and it is being shared by someone else. And at this point in time, I don't want to accept any queries from, so I'm gonna keep going back. One more step back, I can cancel it. All right, now the syntax error, at this point in time, I have the choice of either I can use the exclude option in my configuration file to exclude the folder altogether where that JavaScript is, because we didn't have a lot of Java files. But if I want to, I can just correct that as well and use that as a way to, I guess, continue my scan in full glory. Now, these are just the standard tools that are available from CodeQL. If I keep going back, you can obviously, worthwhile knowing, you can also add tools as well, which takes you back to the workflow screen, and you can set up a workflow yourself. That is how you would identify, enable, as well as triage CodeQL results based on code scanning done by GitHub Advanced Security. That is all I wanted to cover in this lab. I will see you in the next one. It's important to understand how GitHub Advanced Security works with the software development lifecycle. Now, if you're a developer, you probably understand a software development lifecycle, but if you've never heard that before, a software development lifecycle is what you see as a diagram at the bottom. From the time you write your first line of code in your IDE, all the way up to you deploying that into your version control system and all the way into an environment, that entire process is called software development cycle. Now, security can be integrated at various parts, and it's the same with GHAS. GitHub Advanced Security allows you to integrate things like security policies, code scanning, secret scanning, Dependabot, and also provides you a security overview. Depending on the organization you're working for, this may look slightly different, and based on the plan you have with GitHub, this may look a bit different as well. But one thing is for certain, you do want appropriate security access controls for all the findings. You don't really want everyone in your organization to be aware of all the vulnerabilities that I've identified for a repository, especially if it's a production repository. So you may decide and choose to have only a small set of team members or individuals who can access these services and get notifications from them. That is probably the number one best practice I'll call out right off the bat. As you move into a bit more detail on how and what services can be applied, the first security service that I'll call out in GitHub Advanced Security that you can use in your organization, especially if you have a GitHub Enterprise. Unfortunately, this is not available for non-enterprise license. The service that I'm talking about is called Security Overview. Security Overview helps you get an overall security status across all your repositories within an organization. Now, that helps you look at all the risk posture, secret scanning, code scanning, as well as dependencies as well in one good picture. If you are someone who has looked at security policies before, that is usually in the beginning where you can configure how people can inform certain threats that may be in your repository. Usually security team would define the policy and how this can be used to report on any threats. This is usually done at the project configuration status, where you are defining way early before someone code has been put into the repository on how you want your vulnerabilities to be disclosed. This is no particular order, it's just my preference to have secret scanning as the first thing that I normally get implemented. If you're thinking of implementing security into your GitHub pipeline, I would say GitHub Advanced Security Secret Scanning or secret scanning in general could be a good place to start integrating security, because secret scanning is known to most people. And as we have done in other modules here, you probably would understand what secrets are and why you don't want them there. But if it's not implemented, you probably want to work with the security team to integrate that or extend your GitHub Advanced Security to enable secret scanning. The other concept after secret scanning, which is a great place for security, is Dependabot and dependency review. These are looking at dependencies based on the open source libraries that are available in the code. We obviously spoke about in detail about these in the previous modules, so I'll definitely encourage you to find out a bit more. But in terms of who gets actioned or who gets a request here, even though the service may be integrated into your pipeline similar to secret scanning, Dependabot, dependency scanning, as well as code scanning, they all work independently. They all have their own set of results. And based on the organization, you may be working with one or more security team for each one of these, or a dedicated security individual who would be helping you triage these as well. We have been talking about vulnerabilities. It's important to understand how usually security vulnerabilities are reported globally. There are two big parameters: common vulnerability and exposure, which is CVE, and common weakness enumeration, which is CWE. Following is a screenshot from GitHub Advisory, where you can see the rating on the right-hand side with CWE 400, CVE 2024 32476. Now, this number is different for different vulnerabilities and different weaknesses. When I talk about vulnerability, I'm specifically referring to the CVE number, and a CVE score is basically a reference method for publicly known vulnerabilities of a software or a hardware for a particular version of software and hardware. Like it could be a Node.js version 1.0.0 has a certain vulnerability, and that would be disclosed as CVE. On the other hand, common weakness enumeration, or CWE, is a globally recognized reference as well. However, that focuses on type of classes of weaknesses. Rather than here individual versions, it looks as family of class for weaknesses side. This is also a good point to talk about GitHub Advisory Database. That is the URL that I've provided. github.com/advisories is a great way for you to identify all the advisory, security advisory specifically for all the vulnerabilities, CVE packages, and others that have been disclosed. And GitHub maintains a database of all the known vulnerabilities for certain known languages. Now, in case your language is not in the one supported, then I would encourage you to have your own third-party way of identifying threats, CVEs and CWE for the code that you may be running in your GitHub enterprise, GitHub organization, GitHub repository, or GitHub enterprise. Now that you understand where software security development lifecycle can work with security, You also understand advisory and the types of vulnerabilities. It's important to also understand where does the line get drawn for roles and responsibilities. Now, again, I would put the caveat that not everything that I share here is applicable to all organizations. It may be different toward different organizations, but generally speaking, you would know that developers are responsible for developing code. They are usually contributors into a repository, or could be more than one repository. At the same time, there are project owners, project managers, and team leads and other managers who are encouraged to be participating as a username, who are also given a user account in GitHub. The reason for this could be approval required for a certain commit or a certain kind of commit, or it just could be review of the code for the individual contributor who has been contributing the code in. Security team also gets access to repositories that are used by developers. This could be based on secret scanning or any of the other GHAS services. They may have identified something that they want to work on, and they may require access to repositories. So sometimes they may also have a similar role to a developer, depending on how extensive or how involved they are in terms of the repository. Last but not least is GitHub Administrator. This may be in the development team, this may be in the platform team, this may be people who are in the corporate IT department, but they are responsible for managing the security as well as your user management as well as your repository management to an extent, depending on which organization you're talking about. They are responsible for anything to do with configuration of GitHub itself. Like if you need access to a certain repository, they would be able to help you out. And probably the other side of the coin, the security roles themselves, usually there is someone called an application security expert who works with a project team, whether it's a developer or a project owner, to help them triage vulnerabilities that have been identified by the GitHub Advanced Security tool. Now, obviously, there are people who would primarily work on building the workflow for this as well, because they may be just starting off in their journey. They may even only have secret scanning enabled and none of the other GitHub Advanced Security services enabled. So it may be just their job is to figure out what that workflow would be and enable those services. They could also be contributors in one or more repositories, especially if they are talking about security repositories or trying to eradicate vulnerabilities from certain repositories. Which brings me to security policy. Security policy are definitions you can have in a security.md file, which lies in the .github folder of your repositories. You can enable it for entire organization as well if you like, but in general, what they're meant to be is they are a way to security report security vulnerabilities for a particular repository. So in the previous slide, we spoke about the different workflows you may have based on what GitHub Advanced Security service you may have turned on. Each one of them would give you a certain number of vulnerabilities, and depending on how and what you should be doing, that could be defined in the security.md file. So next time you find a vulnerability, definitely look into the security.md file or markdown file inside your .github folder for the repository to identify how can you disclose the vulnerability to the owner of that repository responsibly. Depending on your organization, you may obviously have all of the services turned on, or you may take my advice, and if you've never done GitHub Advanced Security before, you may start off by enabling a secret scanning and then move through dependency alert and then move to code scanning. Irrespective of the path you chose, depending on how many of these services are integrated, the workflow would depend on the rating that your CVE or CWE has. Your organization may decide that any CVE score of 9 and above could mean that you have to escalate to a senior or get your manager involved. However, if it's a low vulnerability, you may not have to do that, and you can just triage that yourself. But what that workflow can look like would differ from organization to organization. But in general, there is a known rating provided to everyone in the organization for them to know on a glance that, hey, if I get a vulnerability which is of a certain CVE score, Or if I get a vulnerability which is marked as high by GitHub Advanced Security, I should use the security policy that I've defined just now in the repository to inform the right people in the organization about the vulnerability that I've discovered and how I can help perhaps remediate that. GitHub Advanced Security Administration. Now, one of the biggest part about administration of GitHub Advanced Security would be to enable GitHub Advanced Security itself. The choices could vary based on how many public repositories, private repositories you may have. As you can see from the diagram here, public repositories have all these services already enabled by default. It's only when you switch to private repository, you would get features only if advanced security is enabled. To enable, you can enable obviously on all repositories in one go, and you can do that across the board on your GitHub organization level by automatically enabling it. The question remains that would you enable that for only the ones that are existing in your GitHub Advanced Security at the moment, or GitHub repository, GitHub organization at the moment, or would you enable that for all new private repositories as well? That is something that you would have to make a decision on and perhaps require an interaction with the other team members and managers to make that call on how much of GitHub Advanced Security would you enable across the board. There are two ways to enable GitHub Advanced Security. One is using the GitHub user interface, simply logging into the website and enabling services either at a per repository level or at the organization level. Or you could use administrative shell provided by GitHub CLI to activate GitHub Advanced Security and perhaps all services of GitHub Advanced Security for your organization in GitHub. The biggest question here, still remember, is should everyone have access to all the findings? And also, should you really have all the services turned on? Or has there been a staged approach so that you're able to identify and remediate vulnerability and not just have a lot of vulnerabilities to triage without having a proper process around it? Now that you've enabled GitHub Advanced Security, you probably want to have restrictions on who can view what alerts and from what GitHub Advanced Security services. You may already be aware that by nature, security vulnerabilities are sensitive, and by the same nature, disclosing all the vulnerabilities to individuals who may not have the right kind of access or may not be even informed about the right steps to take, you may want to be mindful of who you disclose the alerts to. So alert rules, for example, the Dependabot rule for alert, similarly, code scanning alert, secret scanning alert can be used to identify who the appropriate owner would be for any alerts that are created for identifying a code scanning alert or a secret scanning alert or a Dependabot alert. The example shown over here is for Dependabot alert, which you can find in your personal applications, in your personal repositories in GitHub as well. And there are certain amount of minimum permissions required. If you notice, except for code scanning, everything else requires at least a repository administrator or a organization owner role, which is super user level role. So you get administrative privileges. And that's why it would be important for you to think about the workflow that you choose and who you should choose to expose the alerts to. Now, you may need an owner or a security manager to perform. You may need an owner or a security manager permission to view security of all repositories because you decide that, hey, only the security team should have access to it. But you can, like all the other features of GitHub Advanced Security, you can enable this per repo or for a team or for entire organization as well. But this is a great way to identify the overall risk and vulnerability posture of your repositories and projects in your GitHub account. Talking about alerts in your repository, there is a service called Security Overview, which is only available for GitHub Enterprise Plan users. But if you look at the screenshot, It's a great service that helps you look at all your repositories in one single glass pane for knowing what the overall security landscape looks like. Now, whether it's in terms of how many repositories are impacted by code scanning, how many are impacted by Dependabot or secret scanning, and what the overall risk posture looks like. GitHub also provides you with logging in terms of administration. You are able to identify and audit what users have been doing. If you are on a personal account, you get access to things like security log and sponsorship log for all the activity that your user may have performed in that particular account. Similarly, organization level, the security logs are called audit logs, and both organization level as well as personal account has sponsorship logs, which are because you can get sponsor for your repositories. You can also see the activity performed by the sponsors themselves as well. There's another way to manage and administer GitHub Advanced Security. If you have access to GitHub Access Token, which you can easily generate from your GitHub account, you would be able to log into the API and make specific requests for secret scanning or code scanning on Dependabot Alert. Please be mindful, this is an automated way or programmatic way of accessing this. So a lot of the usual features, perhaps audit log or security log, would be the only two helpful things that you can actually find out. You can use to identify if someone is using programmatic access. That would be one kind of administration you may want to do, is now that you know the logs, you know that there is API actions possible, you would use the logging mechanism to understand which user has performed what action in GitHub if there is a suspicious one.